Alright, you guys, a new chapter and a new definition. This one is actually grounded again in some visualization. As you can kind of already see, there's some right triangles that we'll be dealing with. So let's begin by taking what we know right now. I would like to call it our XYR definition. In 2.1, this conversation will happen in quad 1, and then in 2.2 we'll actually expand it to the other quadrants. But the idea, here's our picture right now. So in quadrant 1, right, we're dealing with a angle. So its initial side is along the x-axis, right? I got some rotation going on, creating the angle, and I've got some ordered pair x comma y that lies on the terminal side, right? And so we got r there being the distance from the origin to that ordered pair. So that's our situation that we have going. But I think you've seen me do this in the past, and I'll do it yet again. If we would actually just kind of bring a line segment that's parallel to the y-axis, what I now have built is a right triangle. And so what ends up happening, right, is that this side right here of our right triangle is actually equal to the x-coordinate that's in the point on the terminal side. And this guy right here is actually the y-coordinate that's on that terminal side. And of course we have all our definitions in terms of that, sine, cosine, tangent, right? We know that. I'm going to concentrate on the big ones. For that angle, x is y over r, right? Cosine of that angle is x over r, and the tangent of that angle is y over x. And of course the other three are just the reciprocals. So there's our old working definition and all that. But with our new picture now, right, for this angle right here, it turns out that the y is what we can call the opposite side. So y represents the opposite side of the angle theta, all right? And then x is actually one of the sides that composes or makes up the angle of consideration. So we actually now use the phrase adjacent. So this side used to be x, right? Well, it's still x if you want to use XYR definition, but we are now going to call it the adjacent side. That it's the side that makes up one of the angles. And then r, we know that in terms of a right triangle to famously be known as the hypotenuse. And so I can now come to my trig definition, right? What used to be y over r in our old definition has now become, right, y is now the opposite side of that angle, and r is now the hypotenuse of that angle. So here's kind of the XYR definition, and here's your right triangle definition. So the sine of this theta is the opposite of that theta, right, divided by the hypotenuse. Of course, the cosine of theta, right, that's defined to be x over r. And so what that is going to be defined as, right, now is x is now known as the adjacent side, and r is now being called the hypotenuse of our right triangle. So old and new language, what we're recalling things. And of course the tangent of theta, right, by definition is y over r. And so for our picture, y over x, darn it. And y is the opposite side now of our angle, and x is the adjacent side of our angle. So we now have right triangle stuff. And of course we have the reciprocals, right? The cosecant of that angle is now defined the hypotenuse over the opposite. The secant of that angle is the hypotenuse over the adjacent, and the cotangent of that angle is now the adjacent over the opposite. So new language, new definition, and I playfully call it our right triangle definition of our trig functions, but it's very much grounded in our XYR. We're just relabeling what x, y, and r. And again, right now we're in quad 1. It's pretty obvious that we have that nice smooth transition. So before I cut away and we start doing some homework-like problems, again, in terms of whatever angle, because here's going to be the challenge, right? Whatever angle we're talking about, it's pretty clear what side is the opposite, right? It's the side right across from the angle itself. the adjacent is always going to be equal to, all right, the one of the sides, not the hypotenuse, that makes up the angle. And of course, the hypotenuse is always sitting opposite that 90-degree angle. The reason I mention that, and we'll revisit this in more detail later on, but we also know we have another angle called beta up there. And it turns out we can have the same conversation with beta, where for beta, right, this is now the opposite, this is now the adjacent, and that's still the hypotenuse. So more of that coming later. It's actually going to build some new things. But why don't we go ahead, I just wanted to plant that seed right now about the importance of the definition, what it means to be opposite and adjacent, right? That kind of depends on the angle. So for theta, y is the opposite, right? X is the adjacent. It's one of the sides that makes up the angle. And then, of course, we've got our hypotenuse. So there's our new definition, grounded in it's just basically an extension or a relabeling of our x, y, r's. And then let me go ahead and make another video where we actually apply it to some homework-like problems. All right, see you guys in that next vid.